So my name is Jason Grillo with AirMiners. It's a pleasure to see you all here today. What we're going to do today is unpack a little bit about how AirMiners companies, how direct air capture companies can work with what in many cases is an unheralded resource in our United States national energy resources at the federal level, specifically the National Energy Technology Lab system. These are facilities that are dotted across the country and have an extremely robust ability to have a profound impact on the way early stage direct air capture companies can operate. This springs from, the idea for them has sprung from the conference in Pittsburgh that Tito Jankowski attended, where we learned about all the different resources that NETL has available. And we want to bring this to you, our community, so that you can learn about what is available, because sometimes that does not always filter through. What we're going to do today is is to hear from you what your questions are for some of our esteemed guests from the National Energy Technology Labs. Adina Mangubat, our AirMiners Accelerator Director, is going to be leading the conversation. And it's a little bit of a departure from what we normally do. We're going to have maybe 15 minutes of just audience Q&A, followed by over half an hour or so of your questions of our guest panelists, so that you can learn from them, they can learn from you, and we can go from there. And then we'll stop the recording at the top of the hour for post-event networking. With that in mind, I just want to say once again, thank you for attending, and I wanted to cede the floor to Adina Mangubat. Adina, go for it.
Great. Thank you so much, Jason. All right, folks. As Jason mentioned, I'm the Accelerator Director for AirMiners, and we are here today because we've got a bunch of direct air capture companies that I've been talking to as part of putting together our extension program for the direct air capture teams. And one of the biggest questions that they had is, what happens if I need to do testing? I can't afford all sorts of really expensive pieces of equipment. What can I do? And so we started doing that research, and this is what we have found. So we wanted to make sure that this resource was communicated all the way through. So 15 minutes of Q&A from me, and then we're going to open the floor to y'all. But first, I want to make sure that we have introductions from each of our panelists. So Pam, if you could start, just give us a sense of what your organization is up to, and like what the purpose of that facility is, because each one of you guys has a very, very different setup. So Pam, you go first.
So thanks, Adina. Hi, everyone. I'm Pam Chu. I am coordinating NIST programs in carbon dioxide removal, carbon accounting, and decarbonization. So that's pretty broad. For those of you not familiar with NIST, NIST is an agency under actually the Department of Commerce, not the Department of Energy. Its mission is focused on ensuring quality measurements to support innovation in trade. We do have a growing portfolio, and we're working with our federal partners, such as NETL and others, and the private sector stakeholders to address the measurement and standard needs for CDR. Really briefly, we have a program in benchmark sorbent materials for DAC. We're looking at standards and measurement needs for low carbon cements and concrete. We're working with NOAA and others to look at standards for the ocean chemicals, alkalinity, total inorganic carbon. And we are beginning an effort to look at standard needs for the voluntary carbon market. So that's just a brief overview of our current portfolio, and we look forward to your questions and answers.
Great. Thank you so much, Pam. Dave, what about you?
So Dave Luebke, Technical Director of the National Energy Technology Laboratories Direct Air Capture Center. So NETL is a lab that's really focused on energy. We're very much, in many ways, the carbon lab. We've got strong expertise in point source carbon capture going back 2 decades. So this is capture of carbon dioxide from coal or from natural gas-fired power plants, from industrial processes to reduce the emissions of those, and also in direct air capture. That spans from molecular modeling at that scale all the way up through modeling of plants and process optimization with all the experimental capability necessary to support that. The Direct Air Capture Center is a test bed facility with the mandate to work with technology developers like many of you to accelerate their technologies up to commercialization. So to go out and work with people, find out what their needs are and meet those testing needs.
Great. Thank you so much, Dave. So let's talk a little bit about what kind of testing or what kind of support you can provide to these startups. I mean, you touched on it definitely briefly, but in terms of like the molecular modeling, for example, Dave, that you mentioned, or sorbent testing, I mean, how deep into the weeds are you willing to get, and how does it actually work to work with your lab?
So there are two different approaches to working with our laboratory. You can either do a simple sort of a testing arrangement where you tell us what the experiments are and we go off and do them, and it's, you know, not really much collaboration in the way of research. You just get the data that you need. The other option is we can do collaborative R&D, and that's through an agreement called a CRADA, in which you can access all of the expertise we have here. And I mean, we can go completely into the weeds. If you want to look at the molecular scale interactions of carbon dioxide with your material, we can do that. If you want to look at how long your material lasts when cycling under whatever your conditions are, we can do that. If you want to ask questions like, all right, how am I going to integrate this capture device with some waste heat source or with a grid containing renewable energy, or any of those things, we can do that, and we're happy to do so. The Direct Air Capture Center specifically works at 3 different scales in terms of the testing capabilities that we have. We have a set of material scale units, which are heavily focused on looking at how long do materials last, what's their capacity, what is the ideal process for using a particular material. We have a set of modular scale systems, which are larger, which start to look at issues of fluid flow. And finally, we have prototype scale environmental chambers, which will allow you to look at multiple environmental conditions all in one place here in Pittsburgh.
Amazing. So just to dig a little bit deeper on that, for the CREDA agreements, I mean, obviously intellectual property is a really, really big deal for these companies. So how does that work when working with NETL?
So when if we're just doing the simple performance testing arrangement, then it's pretty simple. We carefully design things so that IP doesn't get produced, right? We're just running some tests for you. In the case of the CRADA, then we'll have part of the intellectual input into the process, and so there'll be joint inventions likely, and what happens to those is negotiated during the CRADA negotiation, and there's a lot of flexibility to sort out how that gets disposed of. Companies have a lot of capability to make use of the IP that gets generated.
Got it. So it sounds like y'all are experienced in actually doing IP agreements relatively quickly. How accurate is that?
I would say that that's very reasonable. I think the relatively so quickly is easy if it's a performance data testing agreement. If it's a CRADA agreement, maybe a little less quickly, because the lawyers have got to have their conversations, and sometimes that takes a bit of time. But
yeah,
we're doing everything in our power to accelerate it.
Great. Thank you so much. I was just notified by Jason Grillo that we have David Scholl here as well. David, if you wouldn't mind doing a quick intro of yourself and your lab and what kind of capabilities it has, that way everybody can get a sense of that.
Thanks, Adina. I apologize for the technical difficulties. I was a little late joining. Pleasure to see Pam and Dave again. I'm David Scholl. I'm from Oak Ridge National Lab. ORNL is located just outside Knoxville, Tennessee. And I lead the Transformational Decarbonization Initiative at ORNL, which is an internal initiative with a very, very strong focus on DAC and also direct ocean capture. But we also have quite a number of capabilities that are available to external partners and external users. And so just briefly, I'll mention 3. We operate for DOE the Buildings Technologies Research Infrastructure Center. This is a user facility for folks interested in using the capabilities that we have. And in particular, we have multiple environmental chambers that are really well set up for testing DAC at lab scales. We can very easily test things relevant to all climate zones and all meteorological conditions for the US. That's why those environmental chambers were constructed for their original use. We've developed capabilities thinking about understanding meteorological conditions for DAC, both on sort of monthly and annual timescales, but also we're developing data sets that will be widely available looking at hourly CO2 concentrations in many locations around the US. And then finally, we've developed modeling capabilities looking at disposition of CO2, so understanding CO2 transportation infrastructure, not only the pipeline infrastructure that exists within the US, which is well mapped and is available through software from Los Alamos National Laboratory, but also inland waterways, rail, and road transportation. And so with those kind of three capabilities, we hope that we can offer things that are really helpful to many of you that are on the call.
Great. Thank you so much, David. Really great overview. I know for a fact that people are going to be interested in the transportation side of the house because we get questions about that all the time in our accelerator. So thanks for doing that. I want to circle back to you, Pam, because your lab is a little bit different in that you're focused really on setting standards. And so I'd love for you to share a little bit more about what kind of benchmarking you're offering and really how you think it can help the community.
Well, great. Thanks a lot. Yes, one of the things that we're doing is, and a traditional thing that we do here at NIST is develop reference materials. So we are looking to reach out to this community and learn a little bit more about what types of materials you would like to have as a benchmark material that you could obtain so that you can make your measurements and then compare it against a reference material that we've measured and characterized. So we have an ongoing effort that's just launching now, and we're pretty excited. Hopefully we'll have a gathering in January to discuss more of the specific stakeholder needs. But right now we have we're more on the very early stage of development, and we have some very basic lab scale capabilities for characterizing these materials, and that's what we're focused on for DAC specifically.
Great. Okay, well, that's been our 15 minutes of rapid Q&A from me. So we're going to open it up to the community. What would you like to ask Pam, Dave, and David? Jason, I know you've been curating in the back.
It looks like we've got Doc from Aeon Blue has a question about CRADAs.
CRADAs, yeah, great.
CRADAs. So yeah, so Doc, feel free to unmute and ask.
Right. So CRADAs with Los Alamos can be pretty prohibitive. They are not an inexpensive partner. They're very well respected. It is the cream of the crop when it comes to verification, but it is not a cheap endeavor. So how would you maybe help me to frame a CRADA with NETL might be more advantageous because I worked at LANL for 10 years and I have contacts there. So I'm curious about how that spreads out across the national lab system.
So I think when you're dealing with a CRADA and you're looking for specific R&D capability for some part of development and process, the cost of it really matters a lot what you need. So some things are very efficient to employ. Some things we've done a lot of times and they're very efficient to employ for a new person who's interested in working with us. If we're doing heavy R&D development, if we're building new capabilities, those sorts of things, that it really does start to get expensive. So I think what I would say in the area of DAC specifically and carbon capture more generally is we have a lot of capability. We've done a lot of things. We've been doing point source capture for 20 years. I've been around here for most of that. So the things that we do reasonably efficiently, and I think we can probably help you to get a reasonable value for the dollars involved in working with us. That's one more thing just to add is that for the performance testing, we have constructed the Direct Air Capture Center specifically to be as efficient as possible to get the absolute best value for dollars that go into it in terms of testing. So as we've talked to people over the past 6 months to a year, nobody has been disappointed or upset by the amount of resources that are necessary for this kind of testing.
If I can keep going for just a second, I became aware of NETL back in the 90s through Bertrand Davis and the pioneering work in Fischer-Tropsch. He wrote the seminal work, and he was one of y'all's central characters. And I'm really curious if that has continued, because it seems like it stopped. So is there ongoing research interest into FT and direct hydrogenation? And
so we have ongoing work in fuels conversion and similar areas. I don't know if we're actually doing any FT these days, but I'm not the right person to answer that question. But if you send me an email, I will get you to the right person.
Great.
And we will,
Thank you
and
so
we will
much,
be
Doc.
sharing, and we will be sharing emails of all the panelists after the event is done. So yeah.
Amazing.
Yep.
Can I
Jason,
just
who do we
add
have
for
next?
context? Can I add for context that
Yeah.
not all work with the national lab has to be done under a crater? And so, as an example, BTREC, the user facility that I mentioned at ORNL, we have a mechanism for doing the sort of thing Dave mentioned, testing contracts that don't involve an elaborate crater. It's so that there are some mechanisms to move relatively quickly, but the gentleman who asked the question is correct that once you want to enter into a crater, then the formalities of IP and so on have to be sorted out, and so that does tend to slow things down a little bit.
Yeah, got it.
And may I also mention that NIST also has a crater program too, of various sorts and sizes depending upon what the people need. So we're happy to work with others as well.
Great. Jason, who's our next question from?
Yeah, it's from Joe James. Hey, Joe. Good to see you again.
Thank you.
Good afternoon, everybody. My company is called Agritech Producers, and we've developed a process by which we plant these very fast and large growing biocrops that go from 0 to 20 feet in 6 months. They capture 4 times the amount of CO2 per acre as an equal acreage of trees over a 15-year period. And if that period was reduced, the differential would be even bigger. We are beginning to do demo projects with utilities to place their underutilized land into a carbon capture situation. Then once we harvest the crops, we convert the plant material into biochar to long-term sequester the captured carbon. I've sent a message to each of the 3 representatives. We have just completed a 12-week, accelerator program in Knoxville, Tennessee, in collaboration with Oak Ridge, TVA, University of Tennessee, et cetera.
Hey, Joe.
We're exploring doing
Joe, what's your
question?
question? Yeah.
My question is, can the 3 representatives respond to my email and allow us to have a dialogue to explore how you might collaborate with us in support of the demonstration projects that we have with utilities to help reduce their carbon footprint?
Joe, in particular, I'll just briefly say yes, I will follow up with you, ORNL. I mean, obviously you're in our area. We have strong partnerships with TVA. We have a very, very large effort looking at soil carbon and bio crops and so on. So I'll look forward to a conversation with you.
Excellent, thank you. And we'd love to have a techno-economic analysis of our process. It's our estimate that our cost of CO2 capture is about $35 a ton. And that's even before we multitask the crops to do other things as well, where costs could be shared. So Pam, I'm not sure if that's where you might help us, but that's another area of interest that we have.
We are not as versed in the techno-economic analyses. I think that's more on the bigger effort in the DOE space, but we are working on standards to underpin that type of work. But I will reach out to you and have further discussions, as well as with Dave Scholl, to talk about soil carbon. So thank you.
Yeah, I guess the last thing I would say, and again, Jason, thanks for the time, is that I'm disappointed that the federal government has not done an analysis of the relative CO2 capture capability of crops and trees, so that people like us could make as broadly informed a decision about which are the best crops and trees over a fixed time period that we can apply to the concept that we've developed. That would be extremely helpful for us.
Thanks, Joe. It sounds like there's a real want to have a follow-up session on this, not just for the DAC side of the house, but for other removal methods. And Pam, I know that you mentioned that you're supporting the ocean alkalinity side of the house, as well as interested in some soil measurement stuff that we talked about earlier. So it sounds like we should have another panel set up specifically to address other methodologies, and we're happy to facilitate that. All right. Other questions on the director capture capabilities, given that we have Dave and David, who are definitely more focused on that side of the house.
Well, looks like we have something from Robert Cummins.
Great, Robert, go ahead.
Yeah, hi everybody. Thanks for putting this all together. We have developed. I'm working actually with DAC City right at the moment. And I'm bringing some technology to the table. We've developed some proprietary nanotechnology, and we have patents on it. And I'm wondering, and now we're applying this technology to not only direct air capture but also sequestration. And I'm wondering well, two things. What are the options we have for working with NETL or NIST? Is one question, and then the second question is there funding available that we could get to because doing research on nanotechnology is quite expensive, and what options do we have of raising funding to do this testing?
So I guess I would start by saying that there is funding available, and that comes from DOE through the Office of Fossil Energy and Carbon Management and several other places. You can find information about that on the NETL website, as well as the FECM and Department of Energy websites. That's all publicly available, and they do their best to publicize those funding opportunities when they arise.
Yeah.
I guess
I'm
question to
actually
you.
working on one of those with them right now. Yes.
Excellent. Well, glad to have you as part of the portfolio. So when you say it matters a little bit what exactly the nanotechnology is that's you're developing as we sort of explore what the possibilities are of working with us. Can you tell us any more about that?
It's based on chitosan, and we've developed a proprietary technology to produce chitosan at industrial scales. And we have patents on the technology, and we're applying this now. I can't really say more about it on this call, but we're applying this technology now to using it for direct air capture, as well as we think there's some opportunities for this with sequestration.
Well, we've got capabilities of looking at the efficiency of those kinds of capture scenarios, and I'd be happy to schedule a follow-up and talk about what details might look like.
Okay.
Great.
Robert, I'll add that within the DOE complex, there are also several user facilities focused on characterization of nanomaterials. So I'll mention at ONL CNMS, the Center for Nanophase Material Science. That's a DOE-funded user facility where it has lots and lots of instrumentation and also modeling capabilities. And so you may want to look at CNMS to understand their capabilities.
Okay. What's the best way to set up a follow-on conversation about this?
Robert, if you follow up with me by email after the call, then I can get you in touch with someone there.
Right.
Okay.
Awesome. Thanks, David. Thanks, Robert. I'm curious, like you can hear in the background of the questions that people are asking, there's kind of this question of like, what kind of capabilities do you have? Because it seems like y'all can do a lot. Is there a list of capabilities for each of your labs somewhere so that the companies know who to go to?
Well, so we will be having a website going up imminently any day now that has a detailed list of everything that we have that we can use to work with people in the DAC space at NETL. I expect that Oak Ridge and yes probably have something similar.
Great.
I'm just about to put our thing into the chat.
Amazing.
Yeah, we do have some lists of capabilities, but I don't think they're broadly focused on this specific area. So, you know, I just encourage at this point people to reach out to me, and I'll direct inquiries where they might fit best. We have a wide range of capabilities across NIST, going from nanotechnology to materials reliability for CO2 pipelines and everything in between. So happy to discuss questions and route them as appropriate.
Great. One more question, and then we'll take a question from Doc. With regards to, I mean, obviously you have a lot of different capabilities, and I would imagine that given that you have so much expertise, that you know you have people banging down your door and you have a line. How much of a line do you have? How long does it take to actually work with you once people, let's say, send you an email and say, hey, I want to engage? Like, what's the timeline for that?
So I'll speak to the DAC center facilities right now. So we are in the process of, so right now the line is maybe 3 to 6 months. So it's not terribly long to get in the door, and that's mostly getting the agreement in place. We are in the process right now of, I told you about 3 scales earlier. We're in the process of putting in place about a dozen of the material scale systems and a half a dozen of the performance systems at the module scale, so that we can eliminate any sort of major queue for working with us. But I mean, the sooner you get in touch, the sooner we can work that out and figure out exactly when we can get the testing done. But we're working pretty hard to ensure that there is enough supply of testing to meet the demand.
Great.
And I would say
David?
roughly the same time scale at ORNL. As I mentioned, BTRIC has on the order of 10 of these environmental chambers. And so, you know, that, yeah, it's typically a few months, I would say, but that is mainly around, you know, getting the right agreement set in place, but also then making sure that people have the right stuff that they can bring to the lab for testing and so on.
Right. Pam, anything you want to add on that? I know that you don't necessarily do as much like testing on behalf of people, but anything you want to add?
So there are possibilities. We have models and simulations and also some very laboratory-based testing materials, and we're happy to talk with folks and entertain some concepts of testing as well. But I think NETL is probably and or Oak Ridge are probably better suited for some of that work at this point.
Great. Okay. Doc, I know I said that we would take your question, but it looks like Pam answered it in the chat, so we're going to skip that. And go to Michael Chi. If you're still here, come off mute and please ask your question.
Yeah, basically I saw that an ETL can testing material property for us. What's the cost associated with that?
So it very much depends on exactly what tests you want. I'm happy to get into details with that. You know, do you want 1 cycle? Do you want 1,000? Do you want 1 temperature of capture and 1 temperature of regeneration, or do you want several? Do you want steam regeneration? We are a very bespoke testing facility, so it'll be based on how much testing time is required to get it done, and we can get you an estimate of what it will cost pretty easily.
Yeah, for example, just one solvent, we just want to test at the absorption capacity of CO2, just 1 cycle. What's the cost roughly about?
It would be low enough that it wouldn't be worth doing the agreement to get it to do 1 cycle. So very, very inexpensive for something like that.
Okay.
Okay.
Thank you.
When you say very inexpensive, just like everybody's definition of very inexpensive is very different. So is it like $50, $1,000, $10,000, $100,000?
It would certainly be less than $1,000. So
okay, great.
Talking about, you know, a couple of hours, 3 or 4 or 5 hours of system time, maybe, which is very inexpensive. So what we've done is we've designed these systems based on all of our previous understanding of testing and may set them up to be as absolutely automated as we possibly can. So it's very much a matter of just loading the material into the system, setting it up for the conditions we want to run, and then forgetting it for 1,000 cycles if that's what you want.
Right. Okay. Rohit Vidhara, you had a question earlier. Please go for it if you're still here. Is Rohit still here, Jason? Do you know?
I can ask it for him because if we're talking about the overhead, I know what his question is.
Okay,
yeah. He
great.
had a question
Doc.
about like, yeah, go for it.
Yeah. So he was asking about the size of overhead in the national lab system, and is that, you know, waived, or is there a way to get ahead of that so that the bill's under 500K?
So I guess what I'd say is that overheads are kind of whatever they are. So in order to minimize the amount of money that gets spent on overheads, we have to be efficient, and that's what we've done. So when I'm talking about the things being inexpensive, that includes all of the overheads that we're talking about. This is not I don't think you're going to get sticker shock working with us on those kinds of things.
And I'll add, Dave, there are several different models that exist. A couple of times I've mentioned DOE user facilities. These are things where the actual facility is explicitly funded by DOE with the intent that it is free to users. And so now the capabilities that can be different than the things that Dave was talking about at NETL. But just so folks are aware, if you hear someone talking about a DOE user facility, there are sort of different funding models that are associated with those than with just general work with the national.
I might just add that, you know, NIST is the same way, but we are somewhat orders of magnitude smaller than DOE. So we have fewer options, I think.
Thanks, Pam. Herlin, you had a question. Go ahead.
So is there any data on carbon pollution per region, like either in the United States or globally? And like, how can we go about acquiring them? Like data that's like trustworthy by scientists, not by politicians?
Helen, are you asking CO2 concentration in the atmosphere or something different?
Yeah.
Yeah. So one source that is particularly useful, it comes from NOAA. It's called Carbon Tracker, and so Carbon Tracker takes many localized measurements, then runs an inverse calculation to attribute CO2 concentrations by location in the US. If folks want to follow up, we've actually been using this data quite extensively. We have data sets for monthly CO2 concentrations on a 1 by 1 degree grid in the continental United States for a particular year, but it doesn't change very much by year. And I mentioned before also there are a number of data sets that exist. They're a little bit more difficult to access, but we're working on making them more available with very high resolution data, hourly data of CO2. And it's quite interesting that often the hourly concentrations vary very strongly, actually, on a sort of daily basis.
So I'll follow up a little bit on that. There is a new greenhouse gas monitoring strategy, and included in it, there's going to be a data center that's stood up. I believe this is with NOAA, NIST, and I believe there's another federal agency associated with that. I'll put a link in the chat for this. Also, there is a lot of data specifically related to cities that NIST has been involved in, doing some measurements and verifying the bottom up and the top down measurement to ensure reliability and comparability.
Okay, and do these data sets have methodologies of measurement attached to that, or?
Yes, the short answer, yes.
Yeah.
Okay, thank you. I appreciate it.
Great. Jason, I'm just going to keep going with the questions that I have in our background queue. What about companies outside of the United States? We have a lot, I mean, this is an international community, right, of companies that are, and people that are all working on this. So what happens if you're located in the UK or in France and you're interested in testing? Is that something y'all can help with, or can you only work with US-based companies?
So I'll say that we haven't actually started or tried to work with anyone who's not US based yet, but the answer to the question I've gotten when I've asked that is there's nothing that prohibits us from doing that. So I think we're able
Awesome.
to do that.
Great.
There
We
tend
are
to be
getting
a few extra hoops to jump through, but it's possible.
Okay.
we are getting much more involved in the international front as well. I mean, that's one of the things that NIST also is engaged in the standards from the international community since. So happy to discuss these things, and we've just had some calls on issues with trade. So that's another area that a lot of these technologies are going to be traded. So we're engaged in that part as well. Not me
Right.
specifically, but others at NIST and in the Department of Commerce.
Right. I mean, really great to hear that it's not just a US based only phenomenon. So really great that y'all can work with people from all over the world, because it's going to take all of us to be able to hit these numbers. So appreciate that. All right. What other questions do we have from the community?
I think Bill Aston had a question.
Great. Bill, go ahead.
I'm very new to all this discussion around DAC and its implementation, but I'm just curious as to, and I'm going to throw this out to the group. Who do you see as an individual that is most articulate and has incredible desire around the subject matter of direct air capture in overcoming some of these conflicts? So it's a general question I'm throwing out to the group, but I'm very much interested in, one, as somebody new to this, but interested in the subject matter, and definition of such. And then two, who are some of the key players?
Well, I'll maybe volunteer that you can see from the number of people interested in this call, there's a huge number of companies that are starting in this area. There are several, companies that have been established for a number of years and are doing things at larger scale than most of the other companies. And so they sort of have more to say about this topic. But I think this is an area of tremendous interest. I think a good thing is if we went, for those of us who had a chance to be at the FECM annual review meeting a couple of months ago, tremendous interest there. But also the fact that now we're really getting into the weeds on the engineering details. And I view that as a positive thing, right? So, Dave and I have been doing this for a number of years, and for a while things were at a pretty high level. And now there's, entire talks about how do you seal your chamber and things like this, which is, maybe not the most exciting thing, but it really matters if you want to do it at scale.
I'm going to permit myself to get into the weeds in this forum here, but I guess what I'm saying as someone from my level, whether it's from an investment perspective or early adoption phase, or maybe downstream mainstream adoption, what might I have to better inform myself? It could be
Bill,
yeah.
What I would actually recommend, if you're an investor, you should absolutely attend our Investor Academy. I actually teach that course, so there you go. And we can make sure that the information for that is sent out as well. But it's available on our website to register for that. And if you're brand new to CDR, I'd highly recommend Boot Up, which is a crash course in all things carbon removal, all the different methodologies, et cetera. And it's also free. The next one's starting in January. So I would definitely check those out.
Thanks.
Links coming. Yeah, links coming your way for all of that. Both the Boot Up and Investor Academy I'll put into the chat here.
Thanks.
Great. Thank you. Doc, you had a question about policy guidance?
Yeah, I wanted to just what everybody, the wonderful panelists have talked about is about sort of the technical competency, the ability to run tests, to develop new materials or standards, to compare a new sorbent or whatever it is that you need. And what I'm curious about is that the policy structure right now is very restrictive. There are a lot of things, especially in Europe, it's quite confusing. They only certify very specific things. There's got to be precipitated calcium carbonate, precipitated magnesium carbonate doesn't count. And so what I'm wondering is, Pam, for instance, in the process of developing standards for comparison for companies like ours, do you participate in policy recommendations? Do you participate in saying, hey guys, here's something I think you might have overlooked about ocean alkalining that, you know, we think needs to be considered by whatever your parliamentary body is, in whatever your jurisdiction is. Here's some evidence that maybe hasn't been considered. I'm kind of exploring that, and because NRC in Canada does that. And so I'm wondering if it's maybe NIST or if it's someone else, and if who.
So we are not as much on the policy front. We are really there to help ensure good measurements and quantification, and that hopefully that gets fed into the whole policy arena. I think we do have some, more informal discussions, but it's nothing formal.
Got it. Okay, great.
Certainly on the standards development side, that's a little different, and we do have, significant engagement on that part.
Thank you.
We had a question from Nick about sorbent testing. Go for it.
Oh, hey, thanks all. Really interesting conversation so far. I think my question is likely towards David Scholl. So I work with Metal Organic Framework up at the University of Calgary, CAF 20 with George Shimizu. We can make it by the kilo, but you know better than everybody that a powder does not do a gas separation. You have to have a structured contactor for it. A lot of that equipment is really difficult to get access to for a chemist making a new source material. Are there any opportunities to access this sort of structuring equipment?
Yeah, Nick, it's a good question. We don't have a specific facility like that. We do have National Transportation Research Center, which they have a lot of interest in monoliths and so on for other applications. That I'd be happy to have a discussion with you and to either brainstorm where we could do that within the national lab system, or more likely to find partners outside, because that's something that we don't have a specific capability.
Cool, thank you.
Great question. Zach, you're next.
Hi, thanks for this panel. This has been very informative so far. So I'm with Offstream, and we're a company that basically what we do is we help CDR developers like DAC companies quantify their carbon removals in compliance with different standards and various compliance frameworks. And one of the challenges that we have right now is finding good publicly available emissions factors for certain parts of the DAC process as it relates to their carbon removals. And so I'm curious if you guys have good resources or places to go to find these emissions factors that are maybe publicly available. Yeah, so that's my question.
So I know that's a great question. I know that there are some issues with activity and emissions relationships. So I think I don't have a good answer for you, but I'll try to seek out who's kind of overseeing some of the development in that end.
Great. Thanks, Pam, for playing air traffic control in that regard and directing people to the right folks. All right, David, any additional comments on that one?
I'll just mention DOE has a program called the Better Climate Program and the Better Planets Program, which is focused on energy efficiency for existing facilities. And so those kind of factors are obviously very important there. If you reach out to me, I can put you in touch with the folks who run the Better Climate Program, because they're specifically interested in helping industrial emitters reduce their greenhouse gas emissions. And so those emission factors obviously are the thing that they care about.
Right. Thank you so much, Zach, for your question. Mike, I'm looking at your question. I'm curious if it's the same, more or less, as Nick's question. If it's different, please go ahead. But otherwise, just let me know is it different or the same? Just let me know.
Yeah, hi. It's a bit similar, but I think it could be framed differently. Mine is just kind of trying to, it's most down to David from NETL, and it's just asking whether on the DAC solvents, whether the modules, the scales, both material scale, modular scale, and prototype scale, whether you can actually develop and characterize different solvent structures like laminates, fibers, powders, and granules, etc.
Yeah, so at the material scale, Mike, we can work with pretty much anything. We can work with a powder, we can work with a chunk of a monolith. Our reactor at that scale is a 2-inch outer diameter tube. And so anything that will fit in there, we can kind of work with. At the module scale, we have a little bit more restriction. We don't really have capability of testing powders anymore. That's a 12-inch by 12-inch cross section. And now you're talking about, we can still deal with something that's granular. We can deal with a fiber mat. We can deal with a monolith, a big variety there still. And at the prototype scale, we're basically giving you a chamber with the atmosphere that you're looking for and supplying utilities to your prototype. So anything that you can build, we can test. As far as characterization, yeah, we have characterization capabilities for looking at those things if that's helpful. Fabrication, some limited capability, but we don't have dedicated facilities for doing things like monolith preparation.
Great. Anything else, other David?
No.
No. Okay, great. I had a question, which is when you're working with teams, obviously getting the agreements in place sounds like one of the biggest time factors in all of this. I'm just curious if there are common things that cause delays in getting started, and if so, what are those? So that way our teams can avoid doing those things.
So I think based on the experiences we've had so far, the longest portion of the discussion running up to actually moving the agreement forward is getting the sort of scope of work in place. So we can talk about the particular capabilities that are available, but until we sit down with someone and go through the process and talk about what they're interested in learning and compare that to what these systems do and decide what data we're going to pull out of them or what cycles we're going to run and those sorts of things, that takes a little bit of time.
Gotcha. The scope of work and experimental design can't rush those. That just takes the time that it takes.
Yep.
Got it. Yeah.
And I'll just add another potential hiccup. It's just remembering that, we are on national lab facilities, and so that means that everybody has to be badged to come to the facility. That takes some time, particularly if you're not a US citizen. It's not an overwhelmingly complicated thing, but again, it just requires a little bit of forward planning, and you can't add another person to your team at the last moment and expect that they'll be able to come on site.
Yeah, makes sense. Thanks for the flag on that. Joe, is your question related to direct air capture, or is it for something else?
Yeah, everything I've talked about is related to direct air capture. The issue is, what do you do with the carbon once you've captured it? So my question is to the panelist, in addition to making biochar, we're also making a bio-based alternative to carbon black filler powder, which is pretty toxic stuff, and it comprises about 30% of a tire. And there's been studies that have come out that shows that it is harmful to health, tire wear. So as a way of sequestering, again, the captured carbon, we're trying to make it into products in addition to biochar. Is anybody, any of the three panelists, are they focused on other types of bioproducts?
I'll answer just in a very general way, Joe. So ORNL, manages the billion-ton report for DOE, which is really focused on the entire bioeconomy. And so there's broad interest in bio-derived products, but not, it's hard to get into the specifics of what you mentioned.
Thanks, David. Next question is from Philip Morkel. Go ahead.
Sorry, I had to unmute. For the Echo-Darwin model, I'm looking at an instance which is going to happen sometime. It could be any time in the next 50 to 100 years. And that would be a gaseous emission, a limnic eruption from a lake, one of the Great Lakes in Africa. And it will release about 2 to 6 gigatons of carbon in a day. It'll be pretty toxic stuff, so it could result in mass fatalities of the order of 5 million. What we're looking at here is, does such a model, as the time sequencing of it, as reading up saying it sort of updates monthly, can you track such an event and see the impact of it? Or could you model such an event and say, what would the outcomes be from an event such as that with that sort of model? Or do you need to get something much more local area to be able to do that? Because our aim here is to use a lake which is trapping a lot of CO2 from atmosphere on a continuous basis, and try and see how quickly we need to evacuate the gas from that lake. Some of it is useful like methane, some of it's CO2, which we could return to the depths of the lake and keep probably stable there for thousands of years. So just the modeling side of this, what do we have and how can we use that?
Philip, I'll try to answer in a very general way. So the folks that do Earth scale system models, of course, the resolution of those models is fairly limited. There are some efforts to put in local point sources. So we actually have a crater with an international company at the moment at ONL where we're doing that. They're thinking about DAC kind of things. So there are, I guess, folks in the broader modeling community who are thinking about those kinds of things. But I think what you just described is a very, very difficult problem to describe in a really thoughtful way.
Well, the thing is, the size of the eruption is equivalent to sort of US total releases in a year. So as a point source impact in a one day, that is like getting on a single day 365 times what the US releases in a year. So would that not show up as a spike in some sort of model measurement and evaluation modeling?
Oh, it certainly sounds like an alarming thing.
It is.
I'm just saying that the Earth's scale models tend to have a resolution of, say, 1 degree by 1 degree or something like that. And so, I think you'd really have to talk to someone who's an expert in those models to understand how it might be incorporated if it is.
Do you guys happen to know who to direct him to in terms of the folks that would be able to speak to those models, or is that not within your jurisdiction?
So at ONL, we're part of the developers for E3SM, which is DOE's integrated model, and Peter Thornton is the lead there. I'll drop his name in the chat.
Right. Thank you, David. Last question is going to be coming from Herlin. You had questions about grant funding for non-US companies. Go ahead.
For US companies, but that are not run by US citizens. Yes, the biggest challenge that I found is that there is a lot of grant funding out there, but because I'm not a US citizen, they're like, oh, the company has to be run by a US citizen. Is there any grant funding for US based companies, but that are run by non-US citizens?
I'm actually not familiar with that restriction, so I don't have a good answer for you. We can probably get you to the right place to ask that question if you send me an email.
Right.
Thank you.
Thanks, Herlin. And thank you, everyone, for your deep engagement in this conversation. And thank you so much to our panelists for being here, for sharing your knowledge, and ultimately for sharing your resources with all of our teams. Jason, I know you've got some quick announcements, so I'll let you take the mic and take it away.
Sure. Thank you, Adina, for an excellent job moderating this whole conversation. I think people learned a lot from it. Looks like people learned a lot from it, and look forward to similar events possibly in the future. So with that, we didn't get to all your questions, and certainly there were some follow-ups. So I shared all the panelist emails in the chat right now. One. Second, how did we do today? Would love to hear feedback, good, bad, indifferent. We want to make events that serve you, our audience, the best. And the only way we can do that is if we hear from you what we did well, or most importantly, where we might have missed the mark so that we can make better in the future. Also, final thing, very, very important. Next Wednesday, the 13th, is our annual AirMiners holiday party called not the Emmys, not the Grammys, but the Carbies. So feel free to come to that. We'll be sharing stories of recognizing other people in our community who really moved things along in carbon removal over the course of the year, people who might have helped you out, people who you thought were really helpful. Those people are going to, if you recognize them in that Carbies celebration, we will provide them a thanks a ton carbon removal e-card, courtesy of AirMiners. So with that, please do register for the Carbies. Indicate what kind of story you want to tell, and we'll go from there. Looking very much forward to seeing you there. With that, I just want to say thank you once again to your audience and to the panelists and to Adina